Hello friends, welcome in this second video lecture. Today we are going to continue our same topic, that is solvent extraction. In last lecture we have studied introduction to solvent extraction, principle of solvent extraction, apparatus used for solvent extraction, and the process how it works. In this lecture we are going to discuss the term distribution coefficient. Distribution coefficient, which is denoted as k to the suffix d, capital D, that is kd. Kd is the distribution coefficient. Now, as per the principle of solvent extraction process, when a solution is placed in separatory funnel, which is to be extracted or separated, and second with an immiscible solvents, then solute is get dissolved in both organic solvent as well as aqueous solvent. Is it right? Again I will repeat. The mixture or components which is to be separated, its solution is initially prepared, and this solution is taken or placed in a separatory funnel. Then to this separatory funnel already two immiscible solvent systems are present, that is aqueous solvent system and organic solvent system. Whenever this separatory funnel is taken in proper way and left for some time, then component or solute which is to be extracted is get distributed, dissolved in two different solvent systems which are immiscible, and after standing they are get separated in both two layers. Okay, then these components are get distributed in two different layers according to a proper proportion or concentration. For example, suppose we have to separate benzoic acid. Benzoic acid solution is prepared in, suppose, acetone. Then it comes in contact with two immiscible solvent systems, that is aqueous solvent system water and organic solvent system, suppose ether, petroleum ether. Then whenever this solute comes in contact with, get distributed in two different solvent systems, immiscible solvent system, then specific type of equilibrium is set up between solute distributed in organic solvent system and solute distributed in aqueous solvent system. Okay, is it clear? That is, some solute is distributed in aqueous phase, some of the solute is get distributed in organic solvent system, and now the equilibrium is set up in this manner. Equilibrium is set up in this manner, that is, the concentration of solute in each layer is become a proper ratio that is the amount of substance distributed in organic solvent system, and some of the amount of solute is get distributed in aqueous solvent system. The ratio is represented by partition coefficient or distribution coefficient, which is denoted by Kd. Means distribution coefficient is nothing but it is the ratio of concentration of solute dissolved in organic phase to the concentration of solute dissolved in aqueous phase. Suppose we are measuring this concentration in terms of molarity, then this ratio becomes equal to Kd is equal to, as shown in the slide, Kd is equal to molarity in organic phase divided by molarity in aqueous phase. So in simple way, what is the definition of distribution coefficient Kd? It is the ratio of concentration of solute in organic phase to the concentration of solute in aqueous phase. In the simple manner, this ratio is termed as a distribution coefficient. It is denoted by K to the suffix D, that is Kd. Is it right? So this is the simple definition of distribution coefficient. Means during solvent extraction, those solute which is dissolved in organic phase, those solute which is dissolved in aqueous phase, this ratio now becomes equal to distribution coefficient. Next, when the compound is placed in contact with two immiscible liquids, then the compound itself gets distributed in these two liquids. See the word distribution. प्रत्येक वेळी आपण हा वर्ड वापरतोय. Whenever substance comes in contact with two immiscible liquids, it is get distributed in these two liquids, that is organic solvent system and aqueous solvent system. Then this is the equilibrium process, that is the amount of solute dissolved or distributed in organic phase and amount of solute distributed in organic phase. Whenever equilibrium is set up, that is this distribution process is totally governed by temperature of system. Temperature of system. See, solvent extraction is the process which is temperature effective process. Most of the time this process is carried out at normal temperature, that is 25 degrees Celsius to 30-35 degrees Celsius. Is it right? So this distribution or equilibrium process is always governed by temperature. Is it right? So the temperature of this solvent extraction process always kept constant at normal temperature. No doubt we know the relationship between distribution and temperature. As the temperature increases, rate of distribution or dissolution increases. But here remember that overall process is carried out at normal temperature, that is normal room temperature. For example, suppose compound A is to be extracted from aqueous solution into organic liquid. समजा एक असं एक कंपाउंड आहे A, we have to extract it from aqueous solution into organic liquid. Then compound A dissolution equilibrium can be represented by equation. म्हणजे समजा आपल्याला ए कंपाऊंड हे ॲक्वियस सोल्युशन मधून एक्स्ट्रॅक्ट करून कशात घ्यायचं आहे, ऑर्गॅनिक लिक्विडमध्ये. मग त्याचं अगोदर सोल्युशन आपण कशामध्ये तयार केलेलं असेल, ॲक्वियस सोल्युशनमध्ये, पाण्यामध्ये समजा. देन वी हॅव टू मेक the contact of second immiscible liquid, that is organic liquid. During this contact and shaking process, the equilibrium setup between A aqueous phase and A organic phase is represented as A in aqueous phase is in equilibrium with A in organic phase. This is the representation. Okay, is it right? So A aqueous is in equilibrium with A organic phase. Now understand, under dissolution of equilibrium concentration, A in aqueous phase and in organic phase is definite, and hence distribution coefficient is nothing but it is the concentration of that solute in organic phase to the concentration of solute in aqueous phase. I think this is clear now. So this is overall about distribution coefficient. Then next, amount remains extracted. I think we have to familiar with amount remain unextracted and extracted. So see these two concentrations. From equilibrium constant coefficient, it is clear that some quantity of compound will be remain unextracted in aqueous phase. दोन टर्म आहेत त्या लक्षात ठेवा व्यवस्थित. Amount extracted in aqueous phase, amount extracted in aqueous phase, and amount unextracted in aqueous phase. Extracted means get totally distributed in aqueous phase. Some of the amount which is not distributed in aqueous phase. So दोन टर्म लक्षात ठेवायचे, एक एक्स्ट्रॅक्टेड म्हणजे टोटली डिस्ट्रीब्यूट झालेली त्या फेज मध्ये, आणि दुसरी अनएक्स्ट्रॅक्टेड मीन्स इट रिमेन्स अनडिसॉल्व्ड, इट इज नॉट डिस्ट्रीब्युटेड. Is it right? So from distribution coefficient we can find out the how much amount of compound is remain unextracted in aqueous phase. First. Second thing, what is the extraction? Suppose initially we are taking two phases in the separatory funnel, that is aqueous phase and organic phase. Then we are going to add solution to the separatory funnel, and this solution now comes in contact with organic phase as well as aqueous phase, and then separatory funnel is shaken. After shaking for 1 minute, we are left the same separatory funnel in a constant way, stationary, and then two layers are separated. That is, uppermost layer is of organic phase and lowermost layer is of aqueous phase. This overall process whenever carried out at initially, then this is called as single extraction. This is the first step, single extraction. But it is practically observed that by extraction process, only one extraction is not sufficient to extract total solute either in aqueous phase or organic solvent system. Hence, number of times this process is repeated, that means single extraction, double extraction, triple extraction, that is number of extractions we have to carry out. I hope that You know what is the single extraction? What is single extraction? So for this half portion we are going to stop here.